this case, I'm giving you a cyclic compound. Okay, and as I said, for cyclic compounds, it is important to understand that the perspective from where we look at the compound. So for cyclic structures, we always stand right in the center and we look over here. So I'm gonna put an arrow here to indicate where I am standing and where I'm looking to. So I'm standing in the center and I'm looking over here. Obviously, I didn't say that before, but we have one chiral center here and one chiral center over here. Okay. So if I'm standing in the center, this is coming above. Okay. Then this is a methyl group CH3. Remember, when there is nothing on the end, it's a CH3. And then everybody must know that then below and away, there will be a hydrogen. Okay. So in that case, I'm ready to assign priorities, and I'm gonna say, okay, bonded to this carbon, we have a hydrogen, a carbon, a carbon, and a carbon. So obviously hydrogen will be 4, and the other 3 is a tie. Okay. So the other 3 are carbons, so we need to look into them. So let's look at what is bonded to each carbon. This carbon here is bonded to 3 hydrogens. So I'm going to write this over here. This carbon is bonded to 3 hydrogens. This carbon over here is bonded to a carbon, 2 hydrogens. Because of the 3 atoms, carbon has the highest priority. That is what I'm going to use to compare. And this carbon over here is bonded to bromine, carbon, and hydrogen. Because bromine has the highest priority, that's what I'm going to use to compare. I'm going to say bromine, carbon, hydrogen. So when I compare the 3 of them, the highest priority here is bromine, which is higher than carbon, which is higher than hydrogen. So priority number 1 will be the carbon on the right side. Priority number 2 will be the carbon on the left side. And priority number 3 will be the methyl group. Okay, so those are my priorities. And then second thing is to make sure the lowest is away from us. If I'm standing from here, the dash bond is a hydrogen, that's away from me. So therefore, I already have the lowest sent to the back. So I'm ready to read. And if I read 1, 2, 3, 1, 2, 3, that's obviously clockwise. So this could be an R carbon. Okay. You can repeat the same for this carbon over here. You will get that this is an S carbon, I think. Yes. So if you look at this one over here, once again, the hydrogen is on the back, bonded to bromine, which would be priority number 1. This carbon will be priority over this one because it's a CCH carbon. So 1, 2, 3, that is 1, 2, 3, that is counterclockwise. So this must be S, I think. Then we will add so to build the name, then we will basically add the stereochemistry to the name. Okay, so in this case, the pattern name will be cyclopentane, and then we have to assign numbers to the groups. In this case, would be the number 1 because it's bromine, alphabetical order. So number 2 would be methyl. So this would be 1 bromo 2 methyl, but because we have 2 chiral centers, we have to also add the configuration. So the real and full name will be 1S, 2R, 1 bromo, 2 methyl cyclopentane. So that's how you do for the any cycloalkane. This is how you follow. I'm gonna give you another example. So what to do in a case that, okay? So in a case like this, I'm gonna show you two tricks. So I can have one chiral center here and one chiral center here. In this chiral center, the methyl group is going away from me, and then obviously I do have a hydrogen coming toward us, above the plane of the molecule. So if we stand in the center and we look through this carbon, I can see that hydrogen is obviously priority number 4. Therefore, hydrogen cannot be in this position in order for the carbon to be read. So I'm going to give you two options how to deal with this. Okay, two different tricks, and you can use whichever is better for you. The number one thing that you can do when you have to read priority, and already you know that the lowest priority is not in the proper position, what you can do also before assigning priority even is to flip the molecule. When you flip 180 degrees horizontally, anything that is wedge is gonna go dash and vice versa, and that is exactly what we want. So I'm gonna do a flipping here, and that's gonna make my life very easy, okay? If I flip 180, and I'm gonna put the arrow here so everybody follows me. So if I do a flip of 180 degrees to the right side, then obviously the bromine is gonna come to the other side, in this case over here, and anything that is wedge is gonna go dash, so this would be the bromine. And this is also a good practice for you in terms of flipping molecules. And then the hydrogen and the methyl will be in the same position, but obviously reversed. So now the hydrogen will be dash, and the methyl group will be wedge. So that would be the flip molecule. And once the molecule is flipped, it's ready to be read once you assign priority, so it makes your life a lot easier. That's what I suggest you to do whenever you have a cycloalkane and the lowest is coming toward you. Flip it first and then do the steps. So we are going to assign priority now. Now, so hydrogen obviously is priority 4. This carbon, this is a carbon, and this is a carbon, 3 carbon. This carbon has 3 hydrogens bonded to it. This carbon has a carbon and 2 hydrogens. And this carbon has bromine, a carbon and a hydrogen. So bromine is the highest atomic number. So once I have this piece of information, I can assign my priorities. Obviously, the bromine is the highest priority here over carbon and over hydrogen. So this could be priority number 2. I'm sorry, number 1. I apologize. So priority number 1 will be this carbon. Priority number 2 will be this carbon. And priority number 3 will be the methyl group. So 1, 2, 3, I can see this is counterclock. So this carbon here is an S carbon. Which is something I knew from the very beginning, because I know that this carbon in this molecule is R, and in this one over here, I reverse the configuration, so the opposite of R must be S, obviously, okay? But anyways, you can do this, and you can do the same for this carbon over here. So you can then assign and build a name for the compound. And in that case, then this could be either 1s, now 2s. So 1s similar to this one because I didn't change the configuration here. 2s, 1 bromo 2 methyl cyclopentane. Guys, if I ask you the relationship in between these two, I'm gonna copy and paste them here because that's something you should be familiar with as well. Relationship in between these two, okay? Same molecular formula, same connections in between the atoms. So these two are stereoisomers. And then I need to look, are they the mirror image of one another? Clearly they are not. Therefore, this is a pair of diastereomers, okay? That's the relationship in between them. You can also tell that this is a relationship by simply looking at the configuration. 1s to R, the enantiomer would be 1r to s. So if you compare the two configurations, they have the 1s is the same configuration, and the second one is opposite, so they must be diastereomers. That's another way to tell. Okay, so you guys need to be familiar with assigning configuration to these carbons because this is something that is important. We will be doing this many times. One second, so I'm gonna square this to make sure that you guys don't get confused with the rest. So it's important to see the relationship in between